morning students. Today we will discuss exercise 1.2 of real numbers, and in this exercise we will discuss about the fundamental theorem of arithmetic. According to fundamental theorem of arithmetic, every composite number can be expressed as a product of its prime, and this factorization is unique apart from the order in which the prime factor occur. It means that every composite number can be expressed as a product of its prime, and this factorization is unique apart from the order in which the prime factor occur. We have the least composite number 4. The least composite number is 4, and it can be factorized in its prime factors 2 into 2. Then next composite number is 6, and 6 can be factorized as 2 into 3. And next composite number is 8, and 8 can be factorized at 2 into 2 into 2. So what do you understand by the composite number? Composite number can be factorized. It has factors just like 4. But 3 is not a composite number because 3 is a prime number. It cannot be factorized. It has only factor 1 and 3. But a composite number must have the factor except 1 and itself also. Just like 4. 4 has 2 into 2. Now if we say 5 is also a prime number. It is not composite because it has only the factor 1 and 5. 5 can be written as 5 into 1. So it has only factor 5 and 1. But a composite factor must have the factor other than 1 and itself. Some other factor should also be there. Just like 6 equal to 2 and 3. So we have different factors 2 and 3 in this composite number. So students, if you have a question and you are asked what is the least composite number, then you will say the least composite number is 4. So this is the fundamental theorem of arithmetic. According to it, that every composite number, whether it is 4, 6, 8, it can be factorized as its prime factors, and this factorization is unique apart from the order in which the prime factor occur. It doesn't depend on the order of the prime factor. 6 can be written as 2 into 3, and 6 also can be written as 3 into 2. So prime factorization should not depend on the order of the prime factors. Now related to this fundamental theorem of arithmetic, we have an example 5. We have to check whether 4 to the power n can end with the digit 0. Means just like 20 ends with the digit 0. Similarly, we have to show that 4 to the power n can end with digit 0 or not. Here what we see that if we factorize 4 to the power n equal to 2 into 2 to the power n, because if we factorize 4, it is 2 into 2. Now it becomes 2 to the power n and into 2 to the power n. So students, if a number ends with digit 0, then it's prime, and we do the prime factorization of this number, then it must contain 2 and 5 both in its prime factor, then it will end with 0. Just like 20 end with 0, then we have 2 into 2 into 5. Its prime factorization contain 2 and 5 both. So if a number ends with digit 0, then its prime factorization contain 2 and 5 both. But what we see that in the prime factorization of 4 to the power n, we have only 2 as its prime factor. So 4 to the power n will never end with digit 0. So if a number ends with digit 0, then its prime factorization must contain 2 and 5. But in the prime factorization of 4 to the power n, we have only 2 in its prime factorization. So it will never end with digit 0. Now student, if you have any queries, then you could ask me in the comment section. I will clear your queries.